Good evening, everyone, and welcome to N-Simplex Pachinko. This is Obi-Wan Pez. Looking to do some more math streaming tonight. Um, so I basically decided this is going to be my default screen here. Also, they changed everything, so I have absolutely no idea where anything is these days. Um, that might help, I guess. Interactive content. Oh, see, now that I threaten them with going to buy like some other awesome software, they decided to be nice to me. Hmm. Oh, that's interesting. Oh, I see. Hello, Superbrain. So you made Wolfram Alpha angry, huh? Oh, I may have also made my tablet angry. Well, all right, Control Z is not even working. That's great. I can still, huh? Yeah, I get kind of nervous when things pop up, and I don't want people to know my name, despite the fact that like it wouldn't be a problem. um, but yeah, it's just inconvenient. That's interesting. Okay, so I can get arrowheads now. I don't think I want arrowheads right now, but this would be good for the Colette's one. So we could also do, instead of galaxy, we could make this one blue. And do arrowheads on these two, and then have all these things pointing. Woo! Alright. So, I'm going to get out of here anyway, and go back to new whiteboard. Okay, we're going to leave the arrowheads on there, apparently. Um, that's not... Hmm. It's not coming with me. Slightly inconvenient. Alright, whatever. It's fine. Graphy background, and bloop. I read an email from you. But question was, did I actually did I retain it? The answer is probably no. So apologies. Um, yeah, I'm sure it's been a week for everybody. So they're, I see. Yeah. So 6-degree polynomials, generally speaking, don't have closed form solutions. but it's possible that that one might. But they might have gone through a few. Huh. They might have gone through a few different experiments to try to figure out like what the solutions to this, your 6-degree polynomial was, and just failed. So it came up with a numerical solution. It's possible that there is a closed form solution and they are not able to find it. Let's see. And simplex pachinko. Nope. Nope. There we go. Ooh, very nice. Yeah, sorry. Oh, exceeded maximum number of characters. I didn't know that. I guess that makes sense that it's possible to do that, but I'm guessing it is not that large of a number. Okay. Yeah, I mean, there's a lot of stuff that I'm not going to be able to parse here, but still looks interesting. Oh, wow. Nice. Arithmetic progressions. Okay. Hmm. Yeah, just, glance over it real quick. Again, there's a lot of stuff in here that, yeah, I'm definitely going to need more time to actually look it over. But, hey, that looks cool. Well, yeah. Thanks for sending that over, because that's fair. Oh, goodness. So let's see what's going to happen. So I'm seeing a shadow here of this bar. Like this bar used to be over here, and now it's still... Really? Okay. Okay. Let's figure out exactly what's going on here with bamboo, because... yeah. That's what I thought it would be. Apparently it's not working. You serious? Undo doesn't work. Yeah, they changed something from last week to this week, and it's a brand new... Wait, really? Oh, you know what? No, it's Dvorak still. But good thought, because every time it resets my computer, it goes back to US. I've told it a number of times that I do specifically. Alright, let's try. Really? Oh my god. What the hell is that? Oh, search bar. Interesting. Okay. Undo. Yep, okay. Okay, so this is fun. It is still... No. I hit both keys and it did not do anything this time. Well, it's an improvement because I selected something earlier and hit delete and it didn't delete it. So, oh man. Well, we'll see how this goes. Whew. All right, so tonight, anyway, I was looking at doing some statistics, specifically statistics that had to do with combinatorics and type stuff like that, since my students are working on that. So it makes the most sense to do things my students are working on. And I accidentally created a problem that they were unable to do. I created two problems that they were unable to do, one of which I solved from looking into my book, but that took far longer than I had intended. Alright, give me 1 second. Let me see if I can just close whiteboard and then come back to it, because this is going to bother me. In the void. Okay. Let's just hang on 1 second here before they throw my face up here. No, okay. Face is okay. Window. Okay. Yeah, I'm starting to wonder if that's what's been going on. Come on. Really? All right. This is fine. Oh god. Anytime he does something with like his keyboards. Yeah, I was like, oh, but you could just do Dvorak because it's so much better. Oh. Okay, fine. Really? Why isn't this loading? It's not helpful? Question mark? So weird. Fine. We'll create a new one. Yet again. Blue and Graphy. Just notes. Nope. Don't know what you want. I'm just gonna go with freehand. Yeah, inking. Might have been because I hit select. That might have yelled at me for something. Anyway. So hi. Anybody who's new here, welcome. This is my absolute disaster of a stream at the moment. Just because Microsoft Whiteboard decided to have a few updates, apparently. And we now are unable to cope. So. Okay. Yeah, so apparently Control Z is actually mapping to the literal Control Z rather than the actual rather than to the like it's mapping to control physical Z rather than control what Z I have. So, you know, where my Z is mapped to. It has now taken it upon itself to remap undo to control semicolon. At least I think, wait, is that semicolon? Also a good question. All right, anyway. Maybe, bottom left corner. So it just mapped it to the physical button at the bottom left corner of the screen. Or of the keyboard. Alright, so anyway, let's look at a couple of things. So I was doing combinatorics this week, and we were talking about all the crazy stuff about probabilities. Ew. Alright, I'm going to move this down. Yeah, and again, delete didn't do anything. And now this thing came up again. What is it? What is it trying to do? Create? That's weird. Okay, well, at least I can hit this and make it go away. Alright, so we are going to look at this in terms of maybe a little bit more advanced to what my students were doing, but yeah, it's possible that like it's just doing a physical mapping, and so it will only look at like the button in the bottom left corner is is the key to use when you do control to make it. I think maybe there are two reasons. One is that it's encoding it, like you're saying. Like it's trying to encode the fact that it's trying to look in a certain place, but that key is no longer there, and it's trying to map it to something else, and it maps it back to the physical location of Z on the physical keyboard. Which again, I'm using a QWERTY keyboard. Like this is a standard QWERTY keyboard. United States QWERTY keyboard. I should say that. So yeah, it could be that it's just trying to like map it to wherever it's being or whatever. Or the other option, and this is potentially better, is that it says, okay, most users prefer to use that whole Control Z thing, and since you aren't using a standard keyboard, it'd be nice and convenient that you wouldn't have to use your right hand at all. Wouldn't it be nice and convenient for you to just use your left hand and do Control Z and just hit the button that's right here? And I mean, that's cool and all. I just wish they would have told me. So if they told me ahead of time, it might have been a better idea. Also that. So like, I really appreciate it when video games that I'm playing decide to go into the settings, read my settings, and then go into the control settings in the game and just say, like, you know, key number 137 or whatever is going to be this. And whatever output I usually see is what pops up there. So instead of your usual WASD, I see, what is that? That is comma AOE. So instead of like WASD, I have comma AOE going across. And like I said, when I see comma AOE in the settings and I don't have to change it, I kind of appreciate that. I just wish it would, tell me that it's doing that. Yeah, my interact is period because that's on the Dvorak keyboard. Some other games like Elite Dangerous, I believe Astroneer, or at least it used to do this, and several others will force WASD and standard QWERTY keyboard. And the other thing that they might do is that they just have it be like a local instance where your settings are WASD, where if you Alt-Tab out to anything else, it's still Dvorak. But if you're in the game itself, it's QWERTY. So they like override your settings, but only locally inside the game, and say, no, you can't use those keys. You have to use these keys. Which again, okay. No, the ones that are bothersome, the ones that are actually bothersome, like I can get over it. If Half-Life says F for flashlight, fine, I can do that. That's not an issue. The ones that bother me are the ones where I have to locally switch to hit my Control Shift to switch the keyboard. So if I physically have to switch the keyboard, not physically, but if I manually have to switch the keyboard back to the other output setting, like that bothers me. I'll figure it out pretty quick though, because I will hit forward and it does nothing. And then I hit left and it goes left. And I hit everything else and nothing happens. Or I hit right and an interact thing pops up. And it's like, okay. So that was the way that Astroneer was for a while. Was I would hit E to go to strafe right, and instead of strafing right, I would pull out the terrain tool. And I'm like, okay. Right, got to change everything back. and then they switched from that to doing local instance, where everything is still QWERTY, but it doesn't tell you that it needs to switch. It just switches it silently inside the game by itself. And again, I've been doing Dvorak now for 13 years, I guess, and I can code switch between QWERTY and Dvorak pretty quickly in my head. It's just I need to remind myself where some of the keys are occasionally. So if it's like QE, if it's Z, X, and C, I can figure that out. If it's V, what's the next one? V, B, I'm not looking. V or B, or F or G, or R or T or Y. Like that stuff I've got, right? It's QWERTY. But yeah, beyond that, I'm pretty lost. So the entire right half of the keyboard, I do not know at all. I have zero muscle memory anymore because I've been doing Dvorak for 13 years. So that's always fun. Alright, so I'm going to look at this a little bit slightly more advanced than my students, just because, you know, I sort of know my audience-ish. And if anybody out there does want to discuss a homework problem or whatever, please interrupt me, because otherwise I just will keep going on. So probabilities, generally speaking, are chances of events occurring. They're going to resolve as like this function P of whatever event you want is going to be between 0 and 1 inclusive. So this is going to allow us to say, well, we want probabilities, the chances of things occurring, to be between some number 0 and some number 1, which are going to be the official, like, lowest value, i.e. it's never going to happen, and highest value, it will always happen. So the probability of me going to work tomorrow is very approximately 1. Right, I don't know exactly what the probability is because something could happen, but I'm just going to say, yeah, I'm going to make it tomorrow to work because I'm determined. So, probability of me going to work tomorrow is very approximately 1. The probability of me getting struck by lightning in the next 2 hours is very approximately 0. Unlike G.H. Hardy, I don't always carry an umbrella. I could do a conditional probability here. The probability of me going to work tomorrow, given that I was struck by lightning, is probably pretty close to 0. But the chance of me getting struck by lightning by itself is going to be pretty low. Alright, we're not doing conditional probability yet. So, chances of events occurring, again, somewhere between 0 and 1. Generally speaking, we have stuff that is called the... Oh boy. Geez, I only did this like 4 days ago. Should remember it. Hmm. There we go. All right, so we have the outcome, which is going to be the result of a probabilistic experiment. We have the sample space, which is going to be the set of all possible outcomes. And an event is going to be defined as one possible subset. I shouldn't say really possible. That's really, come on now. Damn, man. All right. Does that mean I have to gonna have to remap it as actual Control Z, which is then gonna yeah, it's semicolon. All right, one subset of the sample space. Generally speaking, this is just going to be one outcome. And so we get all sorts of cool stuff that we can do, like throwing dice. We can do coins. We can do cards. And we can play all sorts of games that have any sort of equipment or outcomes or anything at all, and start looking at, what are the possible outcomes that we could get? What is the sample space that we're looking at? What are possible events that could occur? And how likely are each of those events? So things like dice, coins, and cards, generally speaking, have what are called independent events. And independent events are events which do not affect one another. So a coin flip okay. Why does that keep coming up? All right, so the outcome of a coin flip does not affect future flips. All right, it's not physically possible. And similarly, coin flip, dice toss, or a single card pull from a deck. All right, so with coin flips, we get stuff like coin flips are really the easiest thing to look at here. The outcomes, well, let's go with the sample space. Generally speaking, we will think of this as H, which is heads, and T, which is tails. There is the slight, although nigh impossible, possibility that we could get E for edge. Right, the probability for heads and the probability for tails should be the same and are very nearly 0.50 or a 50% chance, 50% likelihood for each. In the United States, the chance of landing on an edge is going to be 0, or at the very least, so close to 0, it's not going to matter. Our coins, generally speaking, are very thin. Their edges do have a little bit of, like, roughness to them, at least most of our coins, so they don't tend to stand on the edge, even if you just place it there. The only coin generally that can stand on its edge is a nickel, and that's if you're like really lucky, if you can really get it in place. Like I said, not too many of our coins stand on edge, no matter what you do. I know the pound coin from Britain or the UK. The pound coin from the UK has a nice thick edge to it, and I think that is actually able to land on edge. However, it's really hard to flip it and have it land on edge because if you're flipping it end over end, generally speaking, even if it does, like if it hits it on the edge, it still has a moment of inertia, and so it's still going to try and tumble. If you like make it land kind of on its face and bounce, it's possible that it could then like skip and jump and land on edge, but again, it's practically impossible most everywhere that I've been. The only time you're going to see a coin in the United States land on edge, or a United States coin land on edge, is if it's propped up by something. I can say that with some authority. Pretty much it. Oop. Oh dear. Fascinating. Oh man. Oh, well, have to get used to all this over again. Okay, so this is still dragging. That's good. Okay. Yeah. Nice and thick could potentially happen, but yeah. Or they're not thick. I see. You can tell I have not been to the European Union. Oh man. Yeah, it's been. When was the last time? So we were in Europe in 2012. So it's been 9 years, and that was Paris. So we did actually have euros, but I mean everything was for us. Everything was electronic. We just used cards. I think we had about 10 euros in cash. So for the sample space, generally speaking, what we're going to be looking at is if we want sample space for one flip, then this is going to be heads and tails. And again, most of the time we're going to just ignore edge just because it's so close to 0, it's not going to happen. With 2 flips, we create essentially a Punnett square out of this. It's going to be heads then heads, heads then tails, tails then heads, and tails then tails. With 3 flips, we have a little bit extra of a space to write here. So we've got heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. And so on and so forth. So what becomes important out of this is that the count or the size of the sample space is then going to end up being, where'd I go? Oh, there we go. Lost it a second there. Just delete that one. Don't want that. So for one flip, this is going to be sample size of 2. 2 flips, we have a sample size of 4. 3 flips, we have a sample size of 8, and so on and so forth down. So for n flips, we're going to get a sample space of 2 to the n, or size 2 to the n, possible flips. So for the probability for any particular outcome to occur, probability for any event to occur, is going to end up being the number of successes divided by the size of the sample space. For that particular scenario. All right, where a number of successes you're looking at here is going to be determined by the thing that you're trying to get. So the number of successful outcomes, the number of the number of outcomes which meet the criteria that you want to go for. So here, if we wanted to know what is the probability that we get 2 flips, both heads. Right, we're going to look at the 2 flips category here. We're going to say that for 2 flips, there is one particular outcome which has 2 heads in it. Oops. One outcome out of 4 possible outcomes, which is the size of the sample space. So 1 out of 4 is going to be 2 flips. Both of them are heads. We have a 1 in 4 probability, or a 25% chance. So it's also a 0.25 probability. So probability is, generally speaking, either going to be a fraction in usually simplified form, or then probability as a decimal between 0 and 1, as we said, all the way up to the top. Right, so well, actually, yes. No, that's true. But if we were to look at something like, yeah, okay. I'm just, anyway. I'm fine, I promise. So if we wanted the probability of 3 flips and 2 of them are heads, this is going to build kind of off of what we did up here. 2 flips and both of them are heads. Yeah, if you have an unfairly weighted coin, die, or card deck. So yeah, we'll generalize that one next because, interestingly enough, it has to do with my research. Oh yeah. So with 3 flips, and we want 2 of the outcomes to be heads. Again, we see here that we have 2 heads here, 2 heads here, and 2 heads here. So that's 3 possible outcomes out of the sample space size, which is 8. Yeah, that's one of those that can kind of sneak up on you. So again, 3 flips, 2 of them heads, we end up with a 3/8 probability. Interestingly enough, right, when we're talking about coin flips, this has the useful property that we're going to be looking at the two-dimensional simplex or Pascal triangle or whatever you want to call it. Oh, yeah. Didn't make fun of you too bad, did they? So if we want to look specifically at the fourth row here, this is going to be where we have 3 flips. Remember that this is n equals 0, n equals 1, n equals 2, n equals 3. Oh, I do the same thing. And n equals 4. So when we talk about n flips on a particular n flips for a particular setup or for a particular coin, then what we have is, again, we can just arbitrarily let heads be moved this way and let tails be moved this way. Right, it's completely arbitrary which direction you assign to which. But we get this same random walk sort of thing that we've been talking about the whole time. So you get the pachinko or plinko, as the Price is Right would have it. And the chances of, on 3 flips, getting 2 heads is going to be, this is going to be all 3 heads. This is 2 heads and 1 tail. This is 1 head and 2 tails, and this is all 3 tails. So going across, the number of heads that we have here is going to be 0. Nope. It's going to be 3, 2, 1, and 0, or the number of tails we have is 0, 1, 2, and 3. Alright, so then with our heads and tails split like this, then we can go down and say, okay, we've got 1, 3 is 4, 3 is 7, and 1 is 8. So we have 8 total possibilities going across. And 3 of them end up having 2 heads and 1 tail. So again, 3 out of 8 likely, or 8 equivalently likely possibilities. Now, as Superbrain says, if these are unequally weighted, this becomes much more interesting. Because what we're basically doing is we're saying, okay, give me a trinomial. This is going to be the same thing again in all these cases. But if we go with probability of heads being 0.4 and probability of tails being 0.6. So an unfairly weighted coin towards tails 60% of the time, then what we're basically going to be getting here is a 0.4 plus a 0.6. And usually I think we put H's and T's in here in order to... we don't need to, though. No, it's just the numbers. So we do a 0.4 plus a 0.6, 0.4 plus 0.6, and 0.4 plus 0.6. All right, we make this choice 3 times because we're doing 3 flips. So what are we going to do? The first one, let's say, gets a head, the second one gets a tail, and the third one gets a head. Because again, we still want the probability of 2 heads and 1 tail. So the probability of getting 2 heads and 1 tail is then going to be the product of the probabilities of these things. So the product of the probabilities occurs because these are independent events. So that's an important thing. All right, so the probabilities are going to be multiplied to find the probability of A and B. And And again, that becomes a little bit clearer when you start talking about conditional probability, but we're not doing that yet. So, all right. So then we say we've got if we do this as 0.4, 0.4, and 0.6, or 0.4, 0.6, and 0.4, or, yeah, 0.6, 0.4, and 0.4. It's going to get terribly messy. It's all right. Or 0.6. No, that's the only possibility, right? Because we wanted two heads. So, either the first two are heads and the last one's a tail, or the first and last are heads and the second one's a tail, or the first one's a tail and the last two are heads. Okay, so the probabilities of these things occurring are going to be two heads, which are 0.4 squared, times one tail, 0.6. So we get a 0.4 squared times a 0.6. And again, there are three possible paths to choose in order to get this same probability. So that's going to be multiplied by 3. All right, and then these, when all multiplied together, going to get you 3 times a 0.16 times a 0.6. 6 times 16, that's helpful. 6 times 16 is going to be 96. Yeah. That's over 1. Oh, nope, nope. It's 0.96. 3 times 0.096. There we go. That's what I meant. Multiplied by 3. It's going to give us a 0. Keep doing that. Getting in my own way. Yes, this is why we do fractions. As much as my students hate it, right? It's so much easier to actually work with this in terms of fractions, if that's what you meant. 7 plus 18 is going to be 83. No, 88. 288. Oh, man. This is also why we work from the right to the left. So 28.8% chance. Or the probability of 2 heads, 1 tail, unfair coin. Right, and if you prefer working with rationals, as you all should, it's going to be 3 times this 2/5 squared times 3/5. That's going to be 4/25 is going to be 4 times 9 is going to be 36 over 125. Right, no common factors either because none of the pieces had common factors. So oh man. It's been an interesting day. I mean, your next step is learning how to use the abacus correctly, right? Or did you learn how to do that in like second grade? Anytime. Yeah, my daughter was having some issues with trying to figure out um, uh, multi-step multiplication, and I mean she's had some issues with trying to do math in general, mostly because like she says she doesn't understand. The teacher's like, okay, what don't you understand? And she's like, any of it? And the teacher's like, okay, well, uh, and this is a line that I use too. I probably need to know what you don't understand in order to really help you understand it. And at that point, instead of like me being like, well, let's try and break this down, um, my daughter just kind of puts her hand down and says, never mind. And goes about her business of not understanding what else is going on. And I'm like, don't do that. As a math teacher, please do not do that. Uh, but at the same time, she's like, well, what am I supposed to do? I'm like, well, do you have any questions on ODE? Because that's kind of my specialty. It's not as awesome of my specialty as I would like it to be, but yeah. And that's always the way. A lot of my students will avoid doing examples as much as possible. I'm like, Calc 2 and above students are usually pretty good. They they know more or less what it is that they don't really understand and can communicate it fairly well. Um, I should say even the Calc 1 students. Pre-Calc, they're kind of they're kind of borderline. And then these other students are all in the essentially what is the liberal arts math class. And it's like they don't even know what they don't know. Which, according to many of the famous mathematicians of the age, is always what you should try and figure out first in order to really truly become educated about something. Is figure out like how much of a gap are we talking here? Yeah. Yeah, I may not be able to. That's the other thing is that I'm not sure necessarily about the translation. Not, English and German. I mean, like, are we even talking about the same things? Is there something that you all are covering that I just don't? Like, I've never done before, possibly. Could happen. That's always an eternal struggle, too. It's not knowing what else other people are covering. That's been an issue lately, especially with my pre-calc class. We have been trying to get the other institutions around us to like really nail down what it is that we're supposed to be teaching in pre-calc. And God, we all apparently have so many different ideas about what we should be teaching. Our old dean had us go to a conference and start like trying to run it. I mean, try to run this conference and be like, okay, all of us need to be in groups around the room, and all of us are going to be like the seeds for throwing out ideas for this stuff, and then everybody else in the group who is coming from institutions elsewhere, maybe they haven't thought about this yet, but they're going to hopefully take our ideas and start running with them. Um, so it was a very interesting experience. Ambitious, yeah. It might not be terribly ambitious of him to do that particular material. It's there might just be maybe you all have a slightly different name for it or whatever, or again maybe we don't do polar coordinates, or at least not the same. Uh, hmm. When we do when we do transformation matrices, ABCD on some usually x1, x2, x vector. Prime, right? Hmm. ODE. I think I took all my ODE stuff to school. Cool. Now you just got me interested, so. Oh yeah, this is all Unit 1 stuff. It's way early. Oh well. Orthogonal trajectories. Yes. Yeah, okay. I'm remembering something from a 3 blue 1 brown video as well. I think he was explaining specifically like what are eigenvalues. So it's a zero vector, right? When is the transformation vector going to cause our derivative vector to become 0? I think, right? That's alright. Lambda augmented with 0, 0. Well, it's not even augmented. We just need the determinant. See, I knew there were straight lines. That's when you get A minus lambda, D minus lambda, minus BC is equal to 0. This is AD minus parentheses A plus D lambda plus lambda squared minus BC plus 0. Yeah, lambda squared plus D lambda plus AD minus BC equal to 0. And you're doing quadratic after that. A plus D plus or minus square root A plus D squared minus 4AC D minus BC all over 2. Been a little while. Anyway, yeah. So if you take this, you end up getting some eigenvalues. And then when you're looking at eigenvalues, we're saying we want when is the right, what are the vectors of the steady state for a particular function. So if you end up with eigenvectors, they'll look something like this. Then I think this one's a source. Now I'm wishing I had my notebook. Yeah. So then basically you're transforming this and saying that like these are the orthogonal vectors for this. But I mean clearly they're not actually orthogonal. It's just that this is now your vector space. And these are now orthogonal based on your vector space. So like, congratulations, this is now 1, 0, and 0, 1. You're just making a big map. So right, so under sum mapping, these are just going to be your new unit vectors, essentially. You say, like, lambda is equal to, I don't know, 1 and 3, something like that. And then your vectors, eigenvectors, new. Oh, Xi. We usually use Xi. It's going to be like 1 times some vector. Let's say this is like 4, 1. And Xi2, I'm awful at drawing Xi, but whatever, is 3 times some other vector It's like 2 by 2 by 3, I guess. Or maybe this is 2/3 and 1, and then the 3 comes in, alters that. But either way, like this is your C1, this is your C2, and those are felt like something hit the back of my hand. I'm voting not spider. That's so yeah, maybe this is gonna be like 2/3 1, which is then equal to 2 by 3. So once you get that, then this is now telling us, right, this is now telling us the new unit vectors, which are going to be 4, 1 and 2, 3, or vector 4, 1 and 2, 3. And then that also gives us the solutions to the actual, well, I guess X. Are going to be 4, 1 e to the lambda 1 is just 1 t plus 2, 3 times e to the 3t. And then here we'd also have a C1 and C2 being arbitrary variables, because again, anywhere that you go along these things is going to get you useful vector space. So this is going to be this is essentially our basis for the solutions that exist for X. And it doesn't necessarily mean that this is the only solution, but this is the easiest solution that we can find. There's at least a systematized way to find it. We did stuff in my class anyway, even in our Calc 2 classes, where we were saying, okay, take this particular differential equation and plug in a function to it. And I remember that there were a few of them that, like, I knew what the solution was that I would normally get. Like, I would sometimes just go through and solve it just for fun. And a lot, well, not a lot, but in some of the cases, the functions that they were giving were completely different from the functions that I was finding from our standard method. And it just so happened that it worked. Like, whatever they gave us, it worked in the differential equation. But, you know, there wasn't any way for me to go out there and, like, figure out exactly what it was that they were, or how to get the answer that they gave. I'm always interested by stuff that's different. I mean, in theory, but like one of them could be a second order differential equation like this, right? Where you're going to get a system of first order differential, or you're solving a system of first order differential equations, but your solution is the same as a second order, the solution for a second order differential equation. So we have two linearly independent solutions. So in theory, right, you could come up with a different mapping that works entirely. I guess for something like this, right, it would have to have the same steady state. So in theory, maybe? But the ones that we found were something with e to the t, and the ones that they gave us were something with like maybe it was an alternate mapping, but I was pretty sure it was just a polynomial. Or like a specifically tailored polynomial to make sure that it worked for this particular differential equation. I probably have to find the example somewhere. You know, it's in my notes at school. Yeah. Yes, yes, the Taylor polynomial. Um, I just found out about what was it, Pare? I'm gonna have to look that up again because now I don't remember how it's spelled. Pade, Pade, yeah, yeah, the Pade polynomial. So I found out about that today, and I was looking at the looking at the videos from Dr. Wool, I think. And yeah, that was quite an interesting experience. I wasn't aware that that existed, um, but whatever it was that we were looking up must have linked over as well. Who's Sumi one? I don't know that one. Or I guess some one. Oh, the summer of okay, yeah, yeah, summer of math explainers. So I don't think I had seen any of them. I mean, I saw the Hackenbush one, but I've probably seen a couple other random ones, but that was not my. Uh, I don't think that was my in. There was something else that I was watching though. Um, I was watching a Michael Penn video, and I got linked. Yeah, and I watched the Black Pen, Red Pen was doing something with complex derivatives. I'm not gonna find it now. So he does explainers. Mm-hmm. much in the same sort of style that I do, I think. Where it's just, hey, let's go over something cool. He's got a much better style in terms of like coming up and saying, well, so he does a much better job chunking his videos into 10-minute pieces. Um, I'm pretty awful at that. I mean, obviously live stream, but yeah, there was, even when I was doing other ones, like it got kind of, I was doing 20-minute videos all the time. Just really probably should stop doing that. Yep, Dr. Payam. I did. I've only watched a couple of his videos. He's very enthusiastic, though. I love it. Oh my god. Yeah, I'm just gonna spend the rest of the stream trying to look this up. Anyway. Oh, you were going with that one. Exarchan. Exarch. Nope. Well, thank you for the follow. um. All right, we are. Can't say it any better on my phone. So, if you have any questions about any of the math stuff that we're, whether or not I'm actually working on it, let me know. I will be happy to oblige. All right, hang on one second. All right. Anyway. All right. So when we're talking about probability and statistics, just go off on a tangent for, an hour or whatever. It's fine. So I'm not sure about citation needed, but I have seen a lot of Tom Scott videos. Um, I do like his the direction his channel has taken, sort of in the last year or two, I guess, where it's just like, here's a random thing that I found out about, and it's cool. I am slightly disappointed that some of it is not still, specifically about like the history of computers or whatever. But at the same time, he knows his strengths. So he's like, we're gonna make cool educational videos on just whatever random thing I learn about. Replace Matt, nice. Is that on YouTube or is that the Nebula type thing? I know that he had another show that was on. Okay, he had another show that was on Nebula that I kind of want to watch, but I'm not. I'm not paying for yet another service, so I don't know. Yeah, yeah. I did like his. He has a second channel where he's doing other random stuff. He did one called "I Don't Like Coffee," or "I Don't Like Coffee. Can James Hoffman change my mind?" Um, and like the entire video is just pure joy. I liked watching it. I mean, as a fan of coffee, that is, it kind of helped. And then it also like it was really fun just watching him like explore coffee in general and just be like, "Oh, I get it now." I don't know if it's because I'm old or this is just good coffee. Ah, so you've seen it. Yeah. So with statistics, I pulled a couple of like really bad ideas. And I threw my students a problem. We've been talking about cards for like an hour or something like that. So what's the probability of drawing a black card? Ends up being, 26 out of 52, i.e. 1/2, provided that you're just using the standard deck and not any jokers and whatever else. Um, I was like, okay, what's the probability of, drawing 3 black cards? Okay, so then we've got, well, it's 26 out of 52 times, there's one fewer now, so I have to draw the next one. It's going to be 25, and one fewer total is out of 51. And then again, 24 over 50. The draws are independent events, so their probabilities are multiplied, but the draw on each one keep pulling it back. We're gonna get there. So the draw keeps or the number of black cards keeps going down, and the number of total keeps going down. All of the individual draws are independent, but at the same time, the probabilities do affect each other in that the probability changes after every draw. So you still have to multiply the individual probabilities together, but you know, it's just going to be a straightforward probability for calculating how to get each individual one. So I cannibalized my calculator, didn't I? Man. Yes, I did. We'll just pass for now. All right, satisfied with knowing how to do it, right? So then I was like, okay, what's the probability of drawing 3 black cards in hand of 5? And again, this is a pretty straightforward thing, although at this point they didn't know how to do it, so I was like, okay, well, if we're doing a hand of 5 cards, what's the, what are the different arrangements that you can have for just having 5 cards? And we said, all right, if you have 5 cards, then all right, so 5 distinct cards, the number of arrangements is just going to be 5 possibilities for the first slot, and 4 possibilities for the second, 3 for the third, 2 for the, no, 3 for the, 3 for the third, 2 for the fourth, and then 1 for the last. Thank you. So if we have 5 distinct cards that we're pulling, we're going to have this number of arrangements, and quite frankly, we don't care about how many arrangements or what the arrangements can be, because if you're just drawing 5 cards, you're going to rearrange them anyway in your hand, because, we're all like that. All right, so that means that the number of arrangements that we're going to have are going to be 5 factorial, or that result in the same hand. But then also, we have a number of permutations for the entire deck. And so we're saying, all right, if we do this notation, n distinct objects being put into a group of size R. All right, we want 3 black cards. So this is going to be 3 out of... okay, hang on. No, we want all 5. So we want deck of size 52 to be permuted so that we get 5 cards off the top. It's going to be n factorial over the remaining things. So then this is m minus r factorial. So if we only want 5 cards, then this is going to be 52 factorial divided by 52 minus 5 factorial, or 52 factorial over 47 factorial. So these are the number of arrangements that we don't care about, right? There are 47 factorial arrangements in the deck that we are not going to care about because we're only taking the first 5 cards off the top. which is still an absurdly large number of arrangements. And again, we don't actually care about how those 5 cards are ordered either. So we take this thing and we turn it into 52 factorial over 47 factorial times 5 factorial in the denominator. That gets rid of now the orders in which these 5 cards we picked are going to be. So we're just going to get those 5 cards. So then this is equal to 52 choose rather than permute. So choose 5. All right, and then we said $2.6 million. Yep. Right, so this is going to be the total number of ways to choose 5 cards out of 52. So again, 2,598,960. So that's our number of outcomes. That's our 52. Choose 5. And then the number of successes here, we could say that we want, first of all, anyway, we want 3 black cards specifically to be in that hand of 5. So the black cards constitute 26. So of those 26 cards that we get, we need to choose 3 of them. And then we're going to multiply by the number of possibilities of the rest of the cards in our hand, which are going to be the other 26 cards. So the red cards. Choose 2. Yeah, so that's the number of different possibilities that you can get for those. Now, this is I grant you, right, exactly the number of drawing exactly 3 black cards and 2 red cards in a hand of 5. So this is how that works. If you say at least 3 black cards in a hand of 5, then that changes everything. So you've got to worry about, okay, what happens if we do 26 choose 3, 26 choose 4, and 26 choose 5? So those would become separate things, and since they are distinct from each other, you could actually add them up. So if it was, again, at least 3 black cards in a hand of 5. Then that's going to get us, again, number of successes is going to be 26 choose 3 times 26 choose 2 plus 4 would be 26 choose 4 times 26 choose 1 plus 26 choose 5 times 26 choose 1. Which 26 choose, oh no, 0, sorry. 26 choose 0. 26 choose 0 is just going to be 1, and so it's just 26 choose 5 to get that number of possibilities. For which one? I'm guessing that one. Yeah. Okay, so that's 1625 over 49.98. Seems reasonable. Right, you said about a 32.51% chance. How do you mean fingerprint? Not what I meant. No. Wolfram Alpha doesn't know how to deal with me. Hey, there we go. Third one. Okay. So 26 choose 0 with 26 choose 5. 26 choose 1 with 26 choose 4. I don't think it should be exactly 50, but it's possible. Okay, so I've got 1,299,480 divided by our previous number of 2,598,960. Yeah. 1/2. Yep. Which I guess just thinking about it, that sort of makes sense at least. Um, hmm. Yeah. So anyway, this is part of my problem is that I forgot all about this. Like the fact that you can multiply your chooses together and how to do that. So you're multiplying together like the different ways that you can get the thing you want multiplied by the number of different ways you can get the other stuff. So I was just like, I don't know what I'm doing, and I'm standing in front of everybody like, this is slightly embarrassing. I'm terribly sorry. I shouldn't have done this. I should have come up with an example of exactly what we wanted. But the good news is that, like, after looking this up today, I was able to say, okay, I know exactly what I want to do for this. Or at least 3 red. I mean, literally, it's just complement, so yeah. Alright. Yeah, so the one I actually asked was, what is the probability of receiving 4 aces in a hand of 7? Again, assuming that we're getting the top 7 cards off the deck, which it doesn't really much matter whether you are Yep. Right, they're symmetric to each other. Yeah, exactly. You'll notice I don't have any up my sleeves. It was it worked out pretty well. So I think I mentioned this last week. I did a oh yeah, that's why you mentioned it. I literally had them in my pocket and just quietly they were not impressed. As much as I enjoy thrash metal. Not today. I mean, I thought it went very well because I did this sleight of hand thing and I was like, haha. And yeah, most of them were like, okay. But I mean, the fact is that I was just doing stuff like this, and I'm sure a few of them were like, that's really suspicious behavior. Honestly, probably about the same reaction, or maybe a few more. So the one I asked them was, let's see, like, how would you receive 4 aces in a hand of 7? And then how would that come about? Again, now it's a lot easier to see, like, oh, we just use this stuff up here, the multiplied combinations in order to get what we need. So what are the different combinations we can get of all of our stuff? It's 52 choose 7 for our total number of outcomes, the sample space. But if we want to know then what's the how many different successes can we have, again, this is going to be, well, of the 4 aces, we're going to choose 4 of them. So again, there's one possible way for that to happen. Multiplied by the chance of, or the number of arrangements, no, sorry, the number of combinations of the other stuff in our hand. So the other stuff in the deck is going to be 48 items. And then we're going to choose 3. Because we already have 4 in our hand from the aces, so we just need to choose 3 from the other stuff. then... no, I already calculated this. I have it out on a literal piece of paper in front of me, so that's fine. Alright, so this is going to be equal to 17,296 out of 133,784,560. That's provided that I didn't do something weird when I was trying to calculate stuff, because I was only using my phone calculator. Right. I was trying to basically break these down and do them a la carte so that it would be, 4 factorial being the number of different ways you could receive the aces, divided by, like I was trying to do the 48 factorial here as part of this fraction, but actually it doesn't belong here. It belongs as a part of this fraction over here, which I know, right? It's multiplied. So, oops. There. It's multiplied, so like it's commutative, but at the same time, that's not the numbers that are there. So, yeah. Right, I got 1 in 7,735. Or then about 0.0001292824, and all the rest of that, which makes a 0.0129% chance. So not something I want to bet on. Yes, totally. Yep. Which is why they call me Super... No, wait. Alright, so this is going to be 48 factorial over... This was going to be 3 factorial, 45 factorial. Alright, so then this one ends up being actually 4 factorial, 0 factorial. Which is, again, why this becomes 1. So that whole thing just goes away, and then we're just left with this thing. Again, the number of arrangements that we could have are the number of arrangements of all the other stuff, and then divided by 6, because then we have the order of the cards that are in the hand at the moment. So, yeah, this doesn't belong here. All right. Right, and then you're just gonna, and this is kind of the point, right? Is that you always get some of these terms that are just gonna drop out because, all of the numbers from 48 to 45 are just gonna be eliminated out of here, and then here, this is a bunch of the numbers too, so it's the first 7, right? First 7 numbers, so that's gonna be over 52 factorial over 7 factorial, 45 factorial, right? So then multiply both top and bottom by 45 factorial. And those terms all go away. 45 here with the 45 there, the 45 here with the 45 there. right? And then the 48 and the 52, again, contain all the same numbers. So that's going to be helpful as well. 3 factorial, both top and bottom. 7 factorial. Oof. That almost sounded like a start of a Final Fantasy VII song. Alright, so then this again is gone. This is just 1. This is 1. 3 here with a 3 there. Factorial. 7 factorial with this 7 factorial. So 48 factorial times 7 factorial divided by 52 factorial by 3 factorial. End up getting rid of all this, and then this ends up being 7 by 6 by 5 by 4. This ends up being 52 by 51 by 50 by 49. Right, and then I guess this is also another thing, is that this happens to have values that all are multiples that show up in here. So your 7, your 49, your 6 can have 2 out of here and 3 out of here. Come on now. Work, brain, work. Is that 17? Yeah. 5. It's going to have this be 10. And then the 4. Just has a 2 here and a 2 here. So 5, 7, 13, and 17, all prime numbers at the bottom, and then nothing up top. Like, I want to say it's not a coincidence, but at the same time, I think that there are plenty of other examples we could have done which have other simplifications which are not this. Or which are not 1 over something. So, yeah. Alright, anyway. Main point, again, being this is a really ridiculously unlikely thing to have happen, and we can now figure it out. Right, and then we could do stuff like, you know, the poker type dice game. Everybody's favorite. Now, what's the chances of rolling 3 of a kind after 1 roll? So you're given 5 dice. And again, basically, right, these are 6-sided. So, I'm talking about Yahtzee. We could do the same sort of thing that we did in the last one. If it's only 3 of a kind, right, and nothing else, this means that the options here are going to be that you need to Hang on. Right, this is not this is not a replacement problem. This is going to be the same exact thing. These are truly independent dice. So the chances of rolling anything is just 1. Chance of rolling the same thing is 1 in 6. The chance of rolling the same thing again is 1 in 6. Now this is our 3 of a kind. Alright, and then the other 2 have to be anything else and cannot be the same as each other. So this is going to be... But nope. The first one is going to be 5-6. And then the second one is going to be 4-6. Because again, we can't have that be the same as the other one. Otherwise, it's called a full house. And we just get that. That could be an interesting problem. Right, so the chance of rolling 3 of the same thing is going to be 1 in 36. See, this is why I get stuck. This is still going to be 1-6, isn't it? I keep wanting to say, what, the 1? I mean, it looks correct. Right. It looks correct. This is a problem, though. Alright, so... Oh, no, that was right. That was right. Given what we're looking at. Alright, so you get a 1 out of 36 chance in getting these 2 to be the same as the first one. Then over here, we're saying that 5-6 times 4-6 is going to be the probability that the other 2 are anything else and not the same as each other. So then this is going to be 20 over 36, which either we can simplify or we can just multiply all of that together. So, yeah, let's simplify first. So 1 out of 36 times, this is going to be 4, and 4 is going to make 5/9. It's going to be 5 out of 270, 3, 24. Right, because 54 plus 270 is 324. Anyway. So I'm curious what somebody might rate it. Make sure that it's actually the same. Nope. Alright, they rate it as 250 out of 1296, so I'm probably missing a... Oh wait, that simplifies. Haha. 250 out of 1296. Oops. Is 125 out of 648. Oh crap. Off by a factor of 5 halves. Okay, that I did not see coming. Oh, okay. Hang on. They might be... Yeah, okay. Okay, they might be bringing together a couple of other things. So I think that they... No, that's a full house, though. Yeah, okay. So probability of getting a Yahtzee in one roll is 1/6 to the fourth because, again, whatever the first die rolls, there's a 1/6 chance that all of them are going to be the same. True. Okay. 4 dice, 5 dice. Alright, so for 5 dice, there are 7,776 possible combinations for the 5 dice. Results are shown below. You could use Markov chains to figure all this stuff out. Which I have not done, like, any. Alright, so they got 1,200 out of 7,776, which is 25 out of 162. Oh, man. What did I... What... Alright, 162 is half as much. And 25 is 5 times as much. So... I'm off by a 2 and a 5. So I'm off by a factor of 10. Oh. Alright. So now... Oh. Yep. Okay. Yep. I got it now. No, I know what 10 is. I know exactly what 10 is. Yep. See? Always comes back to it. All right, we don't care what order any of these. Yes, I am. We don't care what order any of these things are in. This has to just be that 3 of them, oops, nope. Of the 5, 3 of them have to be the same. And then we don't care what order they're in. So that's perfectly fine. Yep. All right, so that's 25 over 162 when we divide out 2 from both top and bottom. A. Whew. All right. So technically, right, that's a... Yep. All right. Cool. All right. Anybody else out there interested in getting anything else talked about? Yeah, but then there's probably also a little, like a lot more random other stuff that you can get in there. I've wanted to play um, uh, Vast for quite a long time, and like it plays off of the White Wolf rule set or Werewolf the Apocalypse, and it's oh man, it's such a great game, and it's not actually like you can't watch all of the episodes that came out, and I'm really upset about it because it's just such a brilliant game. You only get to watch, I think, the first 3 episodes or something like that on YouTube, but and you can't actually get like the rules um, because the people involved in it, like all of their IP is locked up with Legendary, and they can't get it out. So anyway, you know, it has been so long since I took any sort of what was that, abstract algebra course that I'm not sure I could even speak with authority on that particular topic. But yeah, um, I mean, changing an isomorphism is changing the structure of something into an equivalent structure, right? So, yeah, in that particular case, taking an isomorphism of an isomorphism is itself an isomorphism, and also taking the inverse of an isomorphism is just getting you back to the other one. So, yeah. I don't know. Are you like are you watching a video where somebody's doing that? Like unless they have a specific you have to Okay. Well, I'm sorry. Yes, I would say probably examples. you, you do the first 2 minutes and you say, and that's about all the time I can spend on just stating this. Now let's look at some examples. Because you could, I don't know if you want to take a dig at the teacher though. That might be a bad idea. Yeah, if he can appreciate the humor. All right. Yeah, I think that is a valid statement. Alright, unfortunately, I think I have to go and actually correct some papers, so... Um, I like having a job, so it's weird. Um, it's this weird relationship I have. Okay, so the two people who followed me, Patricia did it about 7 hours ago. Thank you very much for following. And XRKHXM, I kind of hope you're a real person. Um, thank you for the follow. And I know I said something earlier, but you know. Okay, so today we are, I think, gonna head over to see if Jason Charles Miller's still on. Oh no. Nope, he signed off. Man, where is everybody? Nobody else wanted to stream today either. Um, Alright. I think we are gonna go raid Dev the Devastator, who is a friend of ours for this stream, and he's playing Minecraft tonight. It looks like he's doing some sort of crazy, like, 24-hour stream or something. He's allegedly 20 hours plus in. Oh. But at any rate, I am going to send us over. So thank you everybody for coming. We're going to do some more game stuff on Friday. Going to look at the Forgotten City. So we're trying to rig an election and try to get somebody elected who's not going to commit murder and then immediately cause everybody in the town to get killed. So, you know, just a thought. The Forgotten City has a very interesting plot to it, and I need to go and find if there are any other, like, secrets that are hidden. We already found one that really it's a major plot device, but it's also sort of hidden because it wasn't obvious where it was. So we got to find out if there's more not so obvious stuff just kind of hidden around. So thank you, Superbrain, for coming. Thank you, everybody else, for coming. If I didn't call you out, then specifically, then thank you also for coming. So it's been a good time. We're going to play some games on Friday and then get back to mathematics on next Wednesday. Sometime once school is out. So this is going to be December. When is that? December 20th is going to be the week where I get out, and allegedly I'm supposed to have all of my stuff done by like the 20th. All 4 of my exams are on Wednesday the 15th. I'm not too terribly happy about this, but if I can get everything done within 5 days, then I will be doing stuff. You know, I will be doing extra streams all throughout. So we'll see. Yes, I need to speed run my correction of papers. It's horrible, and I hate doing it, but the problem is that I got to correct most of the stuff by hand. But hey, whatever. As long as I have a key, it'll probably go faster. So, at any rate, December 20th, starting about then, we're going to start doing more streams, and up until January, let's see, sometime around January 17th is when I have to go back and like start really actually prepping stuff. And I think the first, well, technically I think the first day of classes is the 31st. So like we're gonna have a good stretch there where I'm gonna be able to do like a lot of content. I think I'm also going to, yeah. Uh, so I think I'm probably going to do some day streams. So because I'm not going to be physically at school, or I don't have to be physically at school, I think I'm going to do at least one more math stream during the day. So it's going to be like, yeah. So it's going to be like, I don't know, somewhere between probably 9 to 9:30 my time to like noonish, maybe then a little bit in the afternoon. We'll see how things go. I'll just play it by ear because I can do whatever. I'm also going to work on actually getting my content online and put stuff on YouTube for like, stuff like this. Hey, let's do, let's do a probabilistic experiment. Let's do a whole bunch of stuff in pre-calc, which I'm much better at. Let's actually script some stuff. Yeah, yeah. Now, I mean, I want to get out there a little bit more and advertise a little bit more and try to get more people in so that, maybe we can get affiliate. Because that'd be pretty awesome. And if I can stream in a whole bunch of different times during the day, maybe I can get some more audience, not just nighttime streams. So we'll see how things go. But anyway, thanks everybody for coming. This is Obi-Wan Pez for N Simplex Pachinko. I'll see you out there. Have a good time.